We changed t-shirts this
We
time.
swapped shirts. One tip from
shirts.
Atlanta to LA and LA back.
Yeah. All right. So hello, everyone. This is episode number 2 for Pipecat TV. Last episode was not as popular as Mr. Beast, but close enough with a few hundred views. Today we will talk about what did we ship. As usual, we have a special guest who will talk about something super cool that we released yesterday. So first thing, like Mark, what did we ship?
Yeah, sure thing. We shipped since we last did the 2 releases, we had a bug fix release in 0.0.84, but we just shipped 0.0.85. One thing we shipped is a universal context, which lets you use a standard context format with any LLM. Now you have a single context. So why would you need this? It is helpful. So we're going to be introducing new things like strategies to switch LLMs. So for example, if you're using OpenAI and they go down, you might want to switch seamlessly over to Anthropic. So without the universal context, you'd have to have a context that you translate between the 2 vendors. But now with a single context, you can just have a parallel pipeline with 2 LLMs in it and just pass the context to each.
We went right deep again.
Deep. Well,
as last time. I have a quick question
Yes.
for people who doesn't know. What is a context?
If you're working with LLMs, context is like the full kind of conversation, and in voice at least, the conversation body, or really what you feed to the LLM for inference. So that the kind of in its entirety. So every time there's an inference done, you feed it a context. And in the context of real time, you're always aggregating new context, new turns into the context. So every time I speak or a bot speaks, the context grows and grows and grows. So Pipecat maintains that as an object, and you pass it around. So that's what goes to the LLM.
With this universal context,
That's right.
You can use the same exact context with different LLMs without issues.
So keeping it light, we also added, there was a really exciting announcement. OpenAI had their real-time GA, so now you can use that in Pipecat. We migrated to the new API. We're waiting to get access to Azure. Maybe someone out there knows and can hook us up with Azure access.
If someone from Microsoft is watching this, please,
reach out. We used to have contacts, not anymore for some reason. But yeah, Azure OpenAI is coming soon, so stay tuned. And then the exciting news this week, we posted in Discord and announced it yesterday, the new Smart Turn V3 model is available. We have Marcus here to join and tell us all about it. So why don't we introduce Marcus?
Yes, Marcus is the person who worked on this smart AI model, B3 and B2 and B1 actually.
Yeah, thanks. It's good to be here. So yeah, I'll just give a bit of background about what Smart Turn is and what you might use it for. So it's an AI model that is used for determining when a user has finished speaking. So typically, if you have an AI agent that you're speaking to, the agent will wait for the user to be silent before responding. Unfortunately, that can lead to interruptions because sometimes the user is just thinking about what they have to say next, and so they pause. They might be halfway through reading their PIN number and they forget the last 2 digits, and they say it's 52, and then they pause, and the AI model has no idea that they're going to carry on talking, and so it will just interrupt them and think that their PIN number is 52. So the idea with Smart Turn is that it will listen to the words that the user is saying and also how they're saying them, so their intonation and their speed and so on. And so it will make a more accurate decision about, does this user have more to say, or should the agent start responding right now?
So this is all based on the audio wave or of what the user is actually saying. Is that how it works?
Exactly, yes. So there are some solutions for this that work by using the transcript as opposed to the raw audio. And we decided to go with the audio-based approach because there's a lot more nuance that's captured that way. So specifically how people say certain things. So your pitch when you end the sentence, even whether you use certain filler words like and like those are often omitted from the transcript by the speech to text models. Whereas with an audio native model, we can actually make use of all that nuance when making the decision.
So what is different on this new V3, like compared to V2 and V1?
The main difference we've made is to the size and the performance of the model. The new model is actually about 50 times smaller than the previous model. The main benefit of the model being so small is that it's also much faster. So depending on your hardware, it could be anywhere from 50 to 100 times faster than before as well. And what that means is that you don't need a GPU to run the model anymore. You can run it directly on the CPU. One other change that we made in V3 is that we've added more languages. So in V2 we supported 14 different languages. In V3 we've added 9 more, so we've got 23 languages now, and there's a full list of those in the blog post on the daily website.
So now this means you can just deploy it to any instance in Amazon or Google Cloud, whatever, and not very expensive instance, and you can just run it.
We benchmarked a whole load of different AWS instances, just purely running on the CPU with no GPU attached. Even very cheap instances like a T3 medium or a CHE medium, you can get under 100 milliseconds inference, which is actually a lot faster than people are getting with GPUs. Because if you're using a GPU, you've often got to have it running in a different location, maybe with a different hosting provider or some other machine that has GPUs attached. And so you've got that network round trip to actually do the inference. Whereas this time, if you've got, just your simple Pipecat cloud instance running your bot, the model can just run directly inside that instance on the CPU with no network round trip needed.
And you can have your instance with a GPU, but that, of course, is more expensive.
Exactly,
Nice.
yeah. So the model will still run faster on a GPU instance, but not by much. So I'd recommend saving the money and just using CPU.
So Marcus, this model is all open source, right? Can you run it anywhere? I guess you can even run it outside of Pipecat if you were so pleased. Is that right?
Exactly, yeah. So we released the model weights as completely open source, so you don't need to use Pipecat to use it. You can integrate it in your own solution. The license is completely open source, and we've included some sample code in the SmartTurn GitHub repository. The other way, of course, is to use Pipecat, and we've made it really simple. We've actually bundled the model inside Pipecat, so it's a single line of code you need to change. And just one other thing about the open source nature of it. As with version 2 and version 1, we've released the full dataset that we use to train it, so the training and the testing dataset. And we've also released the training script. So if you want to train the model from scratch or make your own modifications to it, you can train it in exactly the same way that we have, and you can also test it in the same way.
That's amazing. Can you say a little bit about the training data itself? I know that you've asked for some help with labeling.
Yeah, definitely. So I think data is normally the most important thing when training an AI model, and just getting the sheer volume of data that you need is a big challenge. So for SmartTurn, we're using a combination of human data and synthetic data. A lot of the data in version 2 and 3 was generated using Google's Chirp 3 model. The general idea with the training data is that we have two categories. We've got sentences which are complete, so a full question or a full response, and we've got incomplete sentences which are sentences where someone ends with a filler word like or are, or they end their sentence with a certain intonation which means they've got more to say. And then with those two categories we can train the model to distinguish between them.
Amazing. Well, if you want to
Thank you
learn
so much,
more,
Marcus.
we'll link in the description where to go find the SmartTurn model. And thanks, Marcus. That was awesome.
Yeah, that was awesome. Thank you so much.
Yep. Thanks, guys.
And I believe that's it for episode 2.
Well, hopefully, we'll figure out the format, but hopefully this is good content and everyone learns a little bit.
If you cannot comment for things you would like for us to share, if it needs to be deeper in detail or higher level is better, whatever you want to share with us, please feel free to add comments. Thank you so much. And next time we run out of t-shirts, so I don't know what we're gonna do.
Got a
Some new
vest I can
ones.
throw on, so I've got at least one more piece of clothing that's coming into this.
Alrighty. Thank you, Mark.
Thanks. Bye.
And thank you, Marcus.
Yes.
See you. Bye-bye.